Today we're going to talk about solving linear equations and inequalities. A few things to remember. Whatever you do to one side of an equation, you need to do to the other side of an equation. That way the equation stays balanced and you don't change the values. And because we're solving, we can check all of our answers. So you must check all of your answers. There's very few things that have definitive checks. Factoring is one of them, and solving equations is another one. So let's solve the following equations and check our answers. First, we have w minus 3 equals negative 2. A lot of my students like to put a line down here. If you cross the line, that's when you're going to do the inverse operation. If you stay on the same side of the line, that's when you're actually going to simplify expressions like we have been in section 2. So we want to get w by itself, so we have to move the 3 to the other side of the line, so we're going to add 3 to both sides. When we add 3 to both sides, negative 3 plus 3 is 0, so we have w, and this stays an equal sign, and then we have plus w equals 1. Negative 2 plus 3 is positive 1. So let's check our answer. We have 1 minus 3 equals negative 2. So that checks out because we put 1 in for w. Just because it's a fraction doesn't mean we can't do it. We're going to do the same thing. We have to move across the bar, so we're going to subtract 3/8 from both sides. Remember, we'll have x equals now, and then we'll do this off to the side, 1/4 plus 3/8. When we add fractions, we need a common denominator, so we'll multiply this one by 2 over 2. That gives us 8 for both denominators, so we have 2/8 plus 3/8 is 5/8. So x equals 5/8. So let's check our answer. Oh, but that was negative. We subtracted 3/8, not added 3/8. Oops. See, everybody can make mistakes. So this is then negative 3/8. So 2 plus a negative 3 is negative 1/8. That's probably going to work a little better. The reason I caught that is because I started doing the check before I was actually writing the check out, and I realized that it wasn't going to equal 1/4. It was going to be a lot bigger than 1/4. So let's check our answer. That's negative 1/8. That's an 8. Plus 3/8. That's 2/8, which is indeed 1/4. So that checks out. If we have negative 4 times u, we need to divide by u. So again, you can still have this, but this is multiplication, not addition and subtraction, so we have to divide both sides by negative 4. So now we have u equals, and over here, let's do this off to the side again. We have negative 8/7 divided by negative 4. Remember, we just finished doing that in the division chapter, so that's negative 8/7 divided by negative 4 would be multiplied by negative 1/4. Negative times negative is positive, and then 8 divided by 4 is 2, so we get positive 2/7. So u equals positive 2/7. So let's check our answer. And we have negative 4 times 2/7. Multiplying fractions, that's 4 over 1, so negative 4 times 2 is negative 8. 7 times 1 is 7, so negative 8/7. So that answer checks out. Now we have 19y minus 4y plus 23 equals 8y minus 19. Let's draw our line again. So 19y minus 4y, that's on the same side. We're not crossing over, so let's simplify that expression first. So that becomes 15y plus 23 equals 8y minus 19. Now we want all the y's on one side and everything else on the other. So let's subtract 8y from both sides because we crossed the line. So we have 7y plus 23 equals negative 19. And now we're going to subtract 23 from both sides. And we have 7y equals, let's see, 12, carry the 1, negative 42. So we have 7y equals negative 42, and we're dividing both sides by 7. So y equals negative 6. I'm going to erase some stuff over here. To check our answer. So we have y equals negative 6. So we have 19 times negative 6 minus 4 times negative 6 plus 23. That's one side of our equation. So 19 times negative 6 would be negative 114 minus 4 times negative 6 would be plus 24 plus 23, so that's negative 114 plus 47, so that is, let's see, we're subtracting, so we have 14 minus 7 is 7, that became a 10, so negative 67. Yep. So our first side is negative 67. Let's see what happens to our second side. We have 8 times negative 6 minus 19. That's negative 48 minus 19, which is negative 67. So both sides are equal, so this is our solution. Versus when we just have a number over here, we have to check to make sure that we're still checking to make sure both sides are equal, but we only have to plug into one equation. So let's try this one now. The first thing we want to do, it's negative 7w plus 42 equals 5 times the quantity w plus 6. So we want to distribute that 5 first. So we have negative 7w plus 42 equals 5w plus 30. Now we want all the w's on one side and everything else on the other. So we can subtract 5w from both sides. And we have negative 12w plus 42 equals 30. And now we're going to subtract 42 from both sides. We get negative 12w equals negative 12. Divide both sides by negative 12. And we have w equals 1. So let's check our answer. Checking in the first side, we have negative 7 times 1 plus 42. So that's negative 7 plus 42, which is positive 35. Checking in the second side, we have 5 times 1 plus 6. You don't have to distribute now. We have order of operations, so that's 5 times 7, which is 35. So both sides are equal. So w equals 1 is our solution. equations with no solutions, one solution, or infinitely many solutions. If you solve an equation and when you're done you find a contradiction, the equation has no solution. So when you solve an equation, if the variables drop out and you get like 0 equals -1, that's a contradiction because 0 is never equal to -1. Then there's no solution. If you solve an equation and when you're done, again, the variables drop out and the statement is always true, so you would get like 0 equals 0 or 5 equals 5, something like that. The equation is a conditional equation and it has infinitely many solutions. If you solve an equation and when you're done you have like w equals 1, 1 is the solution to the equation. And the equation only has one solution. So contradiction is no solutions. A true statement is conditional and has infinitely many solutions. And a variable equal to a number is one solution. Let's see how that works. So let's solve this equation. So we want to distribute over the parentheses. So we have 2y plus 1 plus 7 equals 3y minus 6 plus 2y. And we're going to stay on the same side of the equation and combine like terms that we can. So this side of the equation we can combine 1 and 7. So we have 2y plus 8 equals, this side we can combine 3y and 2y. We have 5y minus 6. Now we're going to solve. Subtract 5y from both sides. This should be 2y plus 2, and so this will be 9. I had a feeling I had something wrong. Let's start over, just so that we get it right. Okay. Distributing, we have 2y plus 2 plus 7 equals 3y minus 6 plus 2y. Now combining like terms, we have 2y plus 9 equals 5y minus 6. Now we can subtract 5y from both sides. We have negative 3y plus 9 equals negative 6. Subtract 9 from both sides and we get negative 3y equals negative 15. We have negative 3y equals negative 15. Divide both sides by negative 3 and we have y equals positive 5. This is a variable equal to a number, so it has one solution, and you can actually check that solution. So 2 times 5 plus 1 plus 7, so that's 2 times 6 plus 7, so that's 12 plus 7, which is 19. And then we have 3 times 5 minus 2 plus 2 times 5, so that's 3 times 5 minus 2 is 3, so 3 times 3 is 9, plus 10 is equal to 19. Both sides are equal, so this is the one solution. Let's see what happens next. So we have negative 4x minus 4, because we distributed, equals 2 minus 4x minus 6. Combining like terms on this side, we get negative 4x minus 4, that side stayed the same, and negative 4x minus 4. If we add 4x to both sides, we have negative 4, because negative 4x plus 4x is 0, so negative 4 equals, again, negative 4x plus 4x is 0, so negative 4 equals negative 4. This is a conditional equation. And there's infinite solutions. So any number you put in here, both sides are always going to be equal. Let's just try two numbers and we'll see. I'm going to erase this part so we can see what happens. If we put x equals 0 in, we have -4 times 0 plus 1. So that's -4 times 1, which would be -4. And then 2 times 1 minus 2 times 0 minus 6. So that's 2 times 1, which would be 2, minus 4. Minus 6 is -4. Both sides are equal. Let's try x equals -1. The reason I chose -1 is because that becomes 0. So we have -4 times -1 plus 1. So that's -4 times 0, which would be 0. And then we have 2 times 1 minus 2 times -1 minus 6. So this is 2 times -1 is positive 2. So we have 2 times 1 plus 2 minus 6. So this is 2 times 3, which is 6 minus 6, which is 0. Both sides are equal. So x equals -1 is the solution, x equals 0 is the solution, and you could keep going on forever. Any number that you put in is always going to be a solution. So let's try this one. Again, we're going to distribute. We have 4x minus 4 minus 1 equals 4x minus 6. Combine like terms on this side. We have 4x minus 5 equals 4x minus 6. Now we can subtract 4x from both sides to get all the x's on one side and everything else on the other. 4x minus 4x is 0 though. So we have -5 equals 4x minus 4x is 0 again. -6. -5 never equals -6. So this is a contradiction. We'll put a big not equal sign in there. And there's no solution. So you could plug in an infinite amount of numbers and you would never get two numbers that both sides equal. Think about what that would mean if we were graphing. How would we never have two lines cross? Next we're going to do inequalities. Inequalities we solve the same way as we would an equality. So only we have an inequality symbol. So the same thing. We can draw our line, only this time we're going to keep our inequality symbol instead of our equality symbol. We want x by itself, so we're going to add 3 to both sides. And we have 2x is less than, because that's our less than sign, 4. We're going to divide both sides by 2. So we have x is less than 2. For these, all you have to do is do a quick graph. That's our graph at 2. You don't need any other any other hash marks. If you do put more hash marks in, make sure you have correct increments, right? That's the same thing we've talked about. It's an open circle because this is not equal to, and x is less than 2, so all the numbers less than 2 go that way. 0 is less than 2, -1 is less than 2, so on and so forth. To check your answer, you pick something in your shaded region. So any number, and you can pick any number that's less than 2. It's easiest if you pick 0, because then your variables drop out. So let's check x equals 0 to see if we find a true statement. So we're going back to our original equation, and we're doing -3 plus 2 times 0. That's -3 plus 0, which would be -3. Is that less than 1? This is true. So that our answer is correct. Let's try this one. We have 4. We're going to distribute our 7 just like we were with our linear equations. So 4 plus 14 minus 7v is less than or equal to 2v. And then we want to combine like terms on this side. So 18 minus 7v is less than or equal to 2v. Add 7v to both sides. And we have 18 is less than or equal to 9v. Divide both sides by 9. And we have 2 is less than or equal to v. 2 is less than or equal to v is the same thing as saying v is bigger than or equal to 2. Notice the bigger side is next to the v, the bigger side is next to the v. 2 is smaller than v, or v is bigger than 2, mean the same thing. So we're going to graph our equation, or graph our inequality. So we have 2. This is equal to, so we're going to fill in our circle this time. And the numbers bigger than 2 go to the right. This time around, 0 is not one of the shaded ones, so we can't check 0. So let's check v equal to let's see, v equal to 5. I like the number 5. So when we do that, we have 4 plus 7 times 2 minus 5. So that's 4 plus 7 times negative 3. 4 plus negative 21 is negative 17. That's our first side of the equation. And then we have 2 times 5, which is 10. So then when we look at it, this side was the left side of our original equation. So 17 is less than or equal to 10. That was our right side. That's true. So our answer is correct. That's it for today.